How do classification algorithms handle missing data? Imagine you're trying to teach a computer to sort emails into spam or not spam, but some of your data is missing. How does the computer handle that? That's what we're exploring today. When working with classification algorithms in supervised machine learning, missing data can be a real challenge. These algorithms need complete information to make accurate predictions, but sometimes data points are incomplete or missing altogether. So, how do they deal with that? One common way is called deletion. Listwise deletion involves removing any data row that has missing values. It's simple but can cut down your dataset a lot, which might make your model less reliable. Pairwise deletion is a bit smarter. It uses all available data for each pair of features, so it keeps more data but can make analysis more complicated. Another approach is called imputation. This means filling in missing data with estimated values. The simplest form is replacing missing values with the average, median, or most common value of that feature. For example, if age is missing in some records, you might fill those gaps with the average age. More advanced methods use statistical models to predict missing values based on other data. For instance, regression models can estimate what a missing value might be based on related features. Multiple imputation takes this further by creating several possible filled-in datasets, then combining results to account for uncertainty. Clustering-based imputation groups similar data points and fills in missing values based on the characteristics of those groups. Some classification algorithms are better at handling missing data on their own. Decision trees and random forests can sometimes split data based on available features even if some data points are missing. They are naturally more flexible with incomplete data. The k-nearest neighbors algorithm can also handle missing data by looking at nearby data points to fill in gaps. Sometimes, missing data is replaced with a special placeholder value like -1000 or a new category label. This way, the model can learn patterns related to missingness itself. The way missing data is handled depends on why the data is missing. If data is missing completely at random, it's easier to deal with. If it depends on other observed data, it's called missing at random. When missingness depends on unobserved data, it's missing not at random, and that's more complicated. Handling missing data properly is important because if you ignore it or treat it badly, your model might become biased or less accurate. In artificial intelligence applications like ChatGPT, DALL-E, or productivity tools, cleaning and completing data is a key step. If data is not handled well, the outputs can be flawed or unfair. In summary, classification algorithms manage missing data by deleting incomplete records, filling in gaps with estimates, using algorithms that are naturally more tolerant, or replacing missing values with special indicators. The method you choose impacts how well your model performs and how fair its predictions are.